Really appreciate it.
Yeah, thank you for having me. I appreciate to be part of that.
We always start these discussions with a little bit of more of a background, getting to know our presenter and our speaker. Could you give us just a little bit about your educational background? What's your journey, your path that got you from getting started in the field of automation and then particularly interested in the industrial applications that you work in today?
Yeah, sure. I started my journey more or less in studying applied software science. So that means like my basis is more in software than in hardware originally. That's where I started. Founded my own startup in the beginning, mainly on software, focusing in web applications, stuff like that. I worked in different companies, mostly smaller ones, before I then joined in 2018 Emerson as a product manager around the topic of IIoT. Throughout my career, I had different positions from leading engineering teams. Let's say I was responsible for sales in between. So I always loved to work closely also with customers and doing projects with them. That was a thing that I really enjoyed. And then starting here in the product management, it was more like a strategic decision, I think, because I started as the first employee, at least in this brand, that was fully working on the topic of IIoT. So I had the chance to really build this topic up, which was a great opportunity and a cool learning as well. So yeah, and today I'm leading the engineering around, it's called today Intelligent Automation within the discrete automation group of Emerson. And we are focused around the discrete industry manufacturing products like valves, actuators, for example. We also have PLCs in our portfolio, so quite broad portfolio. And my role is really like to support the different brands that we have within the group in terms of making their products smarter, in terms of connectivity, for example, or also analytics, but also working on solutions. And those solutions are, in my case, mostly a combination of hard and software. That could be customer tailored, but we also have more and more of those standardized solutions where we have where it feels more like a product, so to say. Yeah.
Well, I appreciate all that experience, both from hardware and software, because so often we hear words like smart and IIoT, and they tend to end up being buzzwords in the industry. And so being able to bring both that experience of the hardware that many people are familiar with and the software that another group is familiar with, and that's going to be a lot of what our discussion today involves. So I really appreciate that experience that you bring in those areas. Now, also, do you have any involvement with other organizations particularly promoting education in engineering and automation? Here at Control.com, we're big on education and making sure that we bring the next generation to knowledge about industrial automation systems. So do you participate or work with any outside organizations that promote automation and engineering?
Yeah, we work closely, for example, with universities that we have locally here, for example, or also others which are more, let's say, in other areas of this world, I would say. And we are supporting, we have students that are working here with us very often, and also we are giving also courses, for example, and try to support, let's say, our future as well in this aspect.
Yeah, that's so important for us to keep in mind that all this experience that people have today is going to have to be somehow passed on to those students and those people that are getting started in the industry right now. So moving into this idea of the floor to cloud concept, I've had the privilege of meeting with Emerson at many recent trade shows. That's one of the things that I love about this job, is being able to learn the vision and the strategy and the whole floor to cloud concept. And these days with that blend of hardware and software, that's becoming easier to attain, but can still be a challenge for a lot of engineers. So for just a little bit of context, being that this is our Control Automation Day with the theme of sensors, in this scope of floor to cloud, what makes sensors such a pivotal role in the vision of the whole concept?
Yeah, so for me, like I would say the sensors are the core because the sensors are the ones that provide the data that helps people like my team, for example, to then start working with this kind of data in terms of data analysis, AI, and things like that. So that's the reason why sensors are, for me, the important data source that helps, let's say, to improve or to reach sustainability goals, for example, or to improve also productivity goals or improvements, let's say. So that's the reason why I think sensors are already important today, and they are part of many, many machines, of course, already. And I think in the future, their role will be even more important because they are the source that really helps to improve the processes and at the end, also the output of a machine, for example.
So in the past, sensors have been obviously really important in all control systems, but this whole floor to cloud kind of looks a little bit beyond just the control. And bringing that IIoT into the picture, does this make it necessary now for people to install new sensors into facilities? Again, that whole idea of the confusion, the difficulty of getting started, people might think, oh, there's so much new technology that I need to install into the facility. And does that include sensors, or are there cases where existing sensors are sufficient for the adventure to IIoT?
That's a very good question. I mean, ideally, and that's also the approach that we try, we use the existing sensors, right? So if you have, for example, a system that has already some sensors available, we try to extract this kind of data and pull this data into our systems so that we can work with this kind of data. Depending on what the customer wants to achieve, there are also, of course, cases where it's not possible to do those kind of things because the necessary sensors are not existing. So typically, I think those kind of data were ending within the PLC, right? Because they were needed for the process. So it could be, for example, an end position sensor that, hey, if that is reached, the next process step starts or something like that, just to give an example. But if you look, for example, on sustainability, then it's a different thing because you need to have, for example, an airflow sensor or an energy meter that is giving you the necessary information about your consumptions. And that means like, depending on what you want to achieve, you might need to add further sensors. But you also, with the original or usual set of sensors, I would say you can do already quite a lot in terms of looking for anomalies, for example, or different behaviors of a machine, a part, a component. So that's the reason why I would say ideally you always start working with exactly the set of products that you have available. That also saves cost, of course. Yeah, was for us often a good starting point.
And I guess it's no surprise to anybody that when it comes to industrial automation, everybody's scenario is going to be slightly different. There's no cookie cutter solution that fits for everybody. And I guess there's the weighing of the challenge of the cost of the new sensors outside of the control system versus the risk of affecting the control system and working directly with the control system. So each case kind of has to be carefully considered as to the customer's unique challenges and priorities.
I think sometimes the customer also don't have access to those kind of data, right? So it might be like, okay, there's a sensor in place and probably the data ends within the PLC, but the customer has no opportunity to get access to those kind of data, to get the data out of the PLC. So that there are, of course, cases where it's not that easy, but we saw many, many cases where it is possible or where you can find ways to mitigate those as well.
Do you find, and again, this I'm sure has many answers depending on the customer, but do you find that a primary challenge, the most significant challenge comes more from those budget concerns of installing new sensors, or does it come more from a lack of knowledge or training from people who are going to be deeply involved with the IIoT modernization project?
I think it's mainly I think, of course, budget. I mean, there are phases in markets where it's a bit more difficult, but usually it's more like the difficulty is more in the combination of these different skill sets that you need. Because if you look at a typical software person, also maybe like myself, right? So, I mean, when I started, I had no clue about a machine or how it works, right? Because I never was in touch with such kind of technologies. On the other hand, if you have a hardware developer, he is pretty much maybe, or let's say a machine builder, he is pretty much aware of how to combine components, how to maybe program a PLC or whatnot. But not so much aware of, okay, what can I do else with the data, for example, right? And how can I do more with it? And that's where I think that's where the most challenge is, probably at the beginning, to bring this different kind of knowledge together, so that the hardware person gets a bit closer and more familiar with the software pieces, and on the other hand, also the same for the software person, getting closer to the hardware, get a at least basic understanding of what is happening and how the things are working. Because that's often what also I experienced in the past when I started here, or when we also worked on very early projects where the engineers didn't have that much knowledge about the hardware. We sometimes had outcomes where then the hardware experts was coming from us and saying, yeah, okay, that looks fantastic, but it's not real, right? So you can't do this kind of things just because it works in software. So that's the reason why I mean, you need to bring this different kind of experience together, and if they find a common language, I think it's definitely possible to solve the puzzle then.
Sounds like what you've been describing is similar, kind of a parallel challenge to what everybody talks about, this IT/OT convergence, which again is kind of a buzzword, but kind of involves two different branches of technology that are both trying to accomplish in the end the same thing, but approaching it from two such different angles that sometimes it's either difficult to see eye to eye. Well, it is difficult to see eye to eye unless both teams are used to or have figured out a way to work together to solve the challenges together rather than separately. The more people you talk to about IIoT projects, you find that everybody recommends starting with kind of a small scale project first, instead of looking at maybe the biggest ROI challenge, looking at something that's easily achievable first. Do you find that there are any particularly beneficial use cases, kind of bringing together that sensing and that analytics, that are most likely to cause success for somebody just getting started?
Yeah, I think you're absolutely right? So first of all, I would definitely recommend to start small. Don't try to make a large project that involves many stakeholders in order to make small steps happen. So this is not the best starting point. So really start with something small. Ideally, of course, with something that will really have an impact. It could be a challenge that you have within your manufacturing, for example, or something that you didn't solve so far in a different kind of way. And that would be, from my perspective, the ideal starting point then, to where you then ideally do a step-by-step approach, right? So in a very agile way, so to speak, come to a point having results in between that you can already showcase maybe as well to others. I think that helps you on the path towards, at the end, having a full solution that is addressing your challenge. So doing these tiny steps, I think they are very helpful, and also help the people around you that might support you or even might be skeptical in the beginning, to show them, hey, look, there is potential, there's something that could be solved. And these are the steps that you did already towards it, right? So I think in terms of topics, I mean, challenges, they differ, right? So of course, I mean, and a few of them I talked already about. Some customers are looking for sustainability goals that they want to reach, right? So for them, it's more like starting like, okay, how can I start monitoring my consumptions in different ways? I might have different types of medias, maybe like steam, water. I might have things like air. I might have things like energy, for example. So how can I start monitoring those? And therefore, of course, maybe sensors are needed if they are not ready and not yet in place. And then the other thing might be, of course, looking at the overall equipment effectiveness, so the OEE, and looking at that and see like, okay, where do you have maybe things that are often breaking down, or where do you have quality issues that you maybe can address with some kind of technologies. So these could be the things where you might start with. Yeah, like I said, don't make it too complicated in the beginning, right? So don't start with something like, yeah, I want to achieve predictive maintenance for my component or my machine, because that's, I mean, even if everybody talks about that, that's nothing easy to start with, right? So that's the reason why start with something maybe more easy. Could be a monitoring, right? Because oftentimes it already starts with the question, okay, how can I get my data out of my system? That's the first question to answer. And then maybe the next step is just like, okay, do a monitoring of those, right? So there are many, many visualization tools out there that you could use to just then visualize the data that you recorded, for example. And based on that, you can do the next step in terms of maybe doing some statistical analysis on the data. And if you are successful with that, you go maybe one step beyond and talk to some data scientists and let them look deeper on the data so that you come closer to your goal. But like I said, really step-by-step approach, do tiny steps that they will pretty much help you on your path.
And I guess by step approach, that could certainly include starting with small realistic goals, but including the different components of what IIoT usually involves, especially as Emerson talks about floor to cloud. When we talk about cloud, it's kind of mysterious, and a lot of people, that skepticism comes from a lack of understanding about it. Is that always a necessary component in every kind of IIoT modernization project? And if the cloud itself isn't a necessary component, there are certain cases where it is beneficial to have a connection to the cloud versus other times when things can be analyzed and processed in-house?
Yeah, very good question. I think generally speaking, the cloud is not always needed, right? And the approach that we take is ideally even doing it in most of the cases locally, because in many cases that saves cost and also help you to scale your project later on. And there's, due to the fact that software is anyway more and more scalable, so to say, automatically, maybe that's the wrong word for it, but it's getting more and more easy. It's not longer a big deal to later on scale a project into a cloud system, for example, in case you have a larger system, for example, or you want to expand the scope of maybe you start at one machine, for example, you want to expand it to your whole facility, for example, and you need to have more computing power, or you do deeper analysis and you need to train your models, for example, your AI models, for example. In those cases, I think it's definitely useful to also utilize the cloud if needed. But I think generally speaking, if you start such a project, I think it's much easier to work first locally with the data and do your first steps. And then when you reach maybe certain restrictions, right, with your systems, you can think about, okay, should I now do the step into the cloud if needed? Or like I said, right, so if you are a bit more advanced and you know already what you want to achieve, and you know, like, you want to train your AI algorithm, which is super complex, for example, or whatnot, right, you of course can do that directly. But I think for most of the people, it's really like, just start, right? Start simple.
Well, I think with what you just said, there was one sentence you just said that's very important, and that's knowing what you want and being able to identify what outcomes you want. And then I assume even a small scale project if you haven't identified exactly what outcomes you want and what tangible results you want from the project, no matter how big or small it is, it's unlikely to really be measurably successful.
That's absolutely true, right? And I think, every company has today their KPIs, right? And maybe there are a few KPIs that could be improved by those. And that's exactly where you can also start with, right? Because you directly have a measurement for those.
For the next little bit, I kind of want to split the discussion up into understanding some of the challenges of, maybe challenges, but also opportunities of IIoT and how it presents itself to those who are more experienced on the hardware side versus those that are more experienced on the software side. And maybe at the risk of generalizing our audience a bit, but a lot of people involved in control systems are veterans of more of a hardware world where they understand the sensors, the PLCs, but the software is a little bit more mysterious to them. And for that group of people, what specific challenges do you see them facing when they have to now be introduced to this software world where analytics, analyzing the information incoming, is going to be a key component of what they need to understand?
First of all, I think it's a bit different world, of course. But it's actually a very good question. So, I think also here I would say, like, if you start thinking about, okay, I have my hardware component in front of me. Okay, so what is this hardware component, or what could this hardware component tell me in terms of data already, right? Because it might be a component or a machine that has already some sensors built in, for example, or if you have certain technologies, for example, that deliver you already some kind of pre-analyzed data or whatnot, right? So it depends really on what you have in front of you. But this would be the starting point also to think about, okay, what's the kind of data that I have? What is the thing that I want to achieve? And do I think I have all the necessary data available for it? If you have already all the data available, great, then really think about, okay, who can you, I would even recommend to work, of course, with some people together which bring these expertise. So could be a consultant, or there are many other companies, of course, out there that help you on those kind of steps, on getting the data out, doing this kind of visualization. And then it's really like a kind of back and forth between the disciplines. But I would also say, like, everyone has its main domain expertise, right? So where, of course, this is what helps you, like, and this should be the knowledge that you bring into the conversation, right? Over time, you will, of course, learn more and more of the other side, or of the other world, however you want to call it. But really work with experts together and find this common language that helps you to understand each other better. Because always keep in mind, probably the person that you're talking to, on the other hand, in particular, if you're a hardware engineer, that's a software engineer, this other person is also missing exactly your piece where your knowledge is about, right? And vice versa, right? So that's the reason why I think these collaboration, finding the common language, thinking jointly about the challenge, that's what helps you at the end.
And that may be something that makes a lot of people nervous when they understand deeply a particular concept. Like those people that have been involved in hardware for so long, they're nervous about coming into a conversation where they may not be experts in the other side of the discussion. But I think that's important for them to remember that without their knowledge, their specific skill set in perhaps that hardware, it's going to be impossible for them, for the project to succeed without somebody who's familiar with the hardware side of it. So while they may not be experts, they're definitely not an insignificant part of any project. Now, when we look at engineering, I again, maybe broadly, it can be categorized into sort of two different ways, and that's designing of new systems, and then there's also maintaining of existing systems, and obviously both have a very critical role. Do you see any differences between those two disciplines and those two function areas when it comes to understanding how analytics and sensing are going to be involved in the day-to-day tasks?
it depends a bit like if who you are, right? So if you are an end customer and you have already an existing machine, it might be maybe a bit more difficult for you to get access than, for example, to the data to come to the initial point, right? So that we discussed. If you are starting at a greenfield and you can plan everything from zero, for example, it's of course much more easier to build those concepts directly in, right? So that might help you, but also need to have, of course, some upfront thoughts that you need to take with the right experts who are helping you, like maybe positioning the right sensors, for example, correctly, or adding additional sensors if needed, right? So those kind of things. I think if you are a machine builder, for example, for you, the game might be a bit easier in that case because you definitely have access to the data via your PLC, for example, and you can much easier get this data out, even if it's an existing machine, for example. You can directly access it and start working on those, right? So that means like for a machine builder, in most of the cases, it's a bit easier. But I would say the most value is at the end created at the end customer itself. Because imagine like your machine is saving some energy, for example. This goes back to your sustainability goals. Or if you improve your outcome of your machine, for example, or the quality, this is directly more output, right, for you that you can sell. So that's the reason why the tricky piece is here really like the value is created at the end customer, but the easier access is, let's say, on the machine builder side, for example.
Now, kind of tying this into a real world example, do you have any example cases where the appropriate sensing hardware was already installed and existing in the facility? Obviously not the greenfield example, but one where the system is already built and now being maintained, but the only thing lacking was the path necessary to collect that data at the appropriate spot and analyze it. Do you have any examples of where that is, just to kind of create a little bit of a tangible scenario for people who are still kind of trying to understand what that might look like?
We had in our own facility where I'm located, for example, we also had the request from the facility manager, hey, can you help us also to monitor, of course, our consumptions as well? We said, yes, for sure. What do you have available? So he was showing to us like what kind of sensors like he has. Some were, of course, also missing, but some others were already existing in the facility. What we already found like is, first of all, you have different protocols of those sensors, right? So some of them were already Ethernet based, some others were not Ethernet based, for example. And you need to, exactly like I explained before, you need to first find the ways like, okay, how can I get the data out of such a system? Or if you think it's too complex for you to solve it, I mean, you can of course also think about installing a different sensor that already has maybe an Ethernet connection available, because in most of the cases that makes it maybe a bit easier than for you to access the data if you don't have any other direct ways in that case. So that's one of the examples where we looked at our internal facility, of course, as a customer, and then looked on, okay, what's available, what can be improved. The good thing is also like if you really start monitoring those, and this is also what really happens in our facility here, is like we had a leak in the water system in between that nobody noticed, and our system was immediately more or less telling the users like, hey, there's a leak. And if they wouldn't have such a system like we have it today, it would take much longer until they noticed like, there's water going out of the system, right? So, and that's the reason why I think such system can really, really help you.
And that specific example with water and fluids, maybe perhaps not everybody works with water systems, but air systems, you could probably analyze many of the same factors, leaks and pressure
Correct.
changes and flow changes, to be able to quickly diagnose where a problem is.
No, that's also absolutely true. So we also had many customers, of course, with pneumatics, and in case of pneumatics, of course, over a certain time, you have some kinds of leaks, right? So they will come. You need to maintain your systems, of course. And so that's also something that you see nicely, of course, in your curves, that over time your airflow, for example, that is needed for a machine will increase. But on the other hand, we also have customers which really, due to the fact of monitoring those, started really to reduce, for example, pressure levels in their facilities. So jointly with them, we were then able to reduce pressure levels sometimes up to 50%. Again, this didn't happen overnight, right? So it's not like that they decide, okay, it's a good idea to change the pressure level, and now we change it from 6 to 3 bar, and everything is done. That's of course not the case. But it also took really multiple years in that case. But the savings are huge that you can gain from it by reducing slowly pressure levels and see, like, is the quality still good enough? If you do such things within your facility, also always keep in mind, like, if you're switching on a machine, that will take a lot of energy or air in that case out of your system. So that means, like, the pressure levels also on other ends might go down as well. And these needs to be considered, right? But there are ways to mitigate those. And working with less pressure, for example, is a huge saving. And also going back to the example of the leakages that which occur over time, with the lower pressure, you automatically have less leakage in the system, because you of course have less airflow that runs through it, right? So that's also then an improvement that you can make. And so what we are currently working at and also showcased already on fairs, with also with some customers, is like a system like that is automatically, for example, locating leakages within the system, so that you can that you are not longer need to run around with an ultrasonic gun, for example, searching for your leaks. The system is automatically telling you, hey, look at this valve or behind this valve, for example. And this is where you have your leak, and this is with such a system, it's then fully automated, right? So you don't need to have any longer a person running around, like I said. But at the same time, you will also notice these leaks way more early. And you can define for yourself also a threshold where you say, okay, now I reached a level where I need to maybe in the next maintenance cycle really improve, let's say, or fix this kind of leaks then. That's one of the examples of what we worked at as a solution, for example.
Well, I kind of have to admit that I'm in more of this hardware category. That's more of my background, is understanding the hardware of the pneumatic systems and valves, things like that, and just having access to some of that information as you're talking. It almost is exciting to me to think about the opportunity of knowing when there's a leak and then being able to form a solution to something, which if you don't have access to the data, all of this is impossible, and you just have to put in measures in place and hope that they're working, or predict where there might be an issue in the future. But suddenly having access to all the information, you can start using the engineering mindset to figure out how would somebody solve the problems, not just today, but in the future, and how can those solutions be quickly applied to new machines. And again, it's just kind of exciting to me from an engineering perspective that none of that is possible without having the data collection and analytics side of the scenario. And now, to get engineers more familiar with this, those hardware engineers like myself, what kind of steps do you recommend as far as the familiarity and the education? Are there courses, online courses to take? Are there schools that teach this kind of material? Are there online versions of tools that engineers can use to become more familiar with more of the software and analytics side, coming from a hardware background?
Yeah, so I think, I would say most companies, they have educational systems where you can book some courses for yourself, for example, or just some online courses. I would also recommend to just, I don't know, use YouTube, for example, for the beginning. For me, that is often a good source. Or also like things like ChatGPT, for example, or other Gen AI systems that help you to, let's say, understand a topic or to get quick access to where to start those kind of things, right? In particular, when you are starting and you have no idea, like, okay, I have this huge mountain in front of me, right? So how can I make the first steps? I think those things could very much help you on getting some insights. Also on YouTube, of course, you find a lot of videos. There are a lot of online platforms. I think the data is available. At the end, it pretty much depends on what's your knowledge level, how deep you want to go before you actually start maybe a project. And at the end, also like, hey, do you like the person that is telling you something about the subject, right? So that's also, of course, an important topic.
Finding trustworthy counselors.
Yeah, for sure.
Yes. Well, now I want to kind of turn the discussion the other direction. We've been talking about those engineers with a hardware background for a while, and now maybe this is more familiar to your own background, but those with a software perspective coming into the hardware control system world. What sort of specific challenges are they going to face? Are they different than those that are facing a more of a hardware-centric engineer?
Yeah, I think definitely yes, because software approaches are oftentimes way more agile in terms also of how you develop those, right? Where, hey, when you have a developed valve, it's developed, right? I mean, of course, you do maybe sometimes some adjustments or whatnot, right? But in most of the cases, hey, that's your valve, right? So you're not changing it so quickly. When you look at software, it's of course a complete different world because changing something is like done, yeah. So you can quickly do those kind of things, and so that's a different mindset. So that I think when you look on it from a software engineer perspective, that you need to understand that hardware is a bit more fixed in that terms, so to speak, and you have different constraints, of course. And the other thing is also like really a recommendation from my end based on my own experience is also like don't forget the reality if you start doing kind of analytics, right? So because like I mentioned in the beginning, you will step into things where the experts will tell you, hey, that's nice result, but not longer realistic. So I think on the path towards that, I think try to understand how the hardware works. Really, also if you look on a machine, try to understand what are the steps that are happening, what are the elements that are available, because it could be also for a software engineer, it could be a lot, right? Because you have valves, you have sensors, you have a PLC, you have actuators. Different kind of actuators, pneumatic ones, electrical ones, and all have different kinds of data available, right? So that is also a huge new environment, similar to what probably also the hardware engineer looks at in the beginning, right? And it's a complex thing to start with. So that's the reason why start with really understanding at least the basic concepts on, okay, how does such a system work, right? So how is a pneumatic cylinder moving, for example, right? What is needed for that, right? So it's just a valve, right? So what is the flow of air, for example, through such a system? And then you can think about, okay, also like, okay, which kind of data I have available in such a system, right? Do I have, for example, end position sensors at my cylinder, or a position sensor, or do I have an airflow sensor, for example, to be more around the pneumatics here again? And then think about, okay, what kind of data does it have? And in general, it doesn't matter if you are a hardware or software engineer, don't hesitate to ask the stupid questions, right? So really, I know it's difficult in the beginning because, it's this huge mountain in front of you. But I think those stupid questions help you, and I guarantee you that the person that is sitting in front of you, looking then from a hardware or software perspective, this person might have the same or a similar question to you where you have your expertise in, right? So don't hesitate to ask those.
Exactly. Yeah, everyone that has their areas of expertise, and there's no shame in not understanding someone else's area of expertise.
Yeah, exactly, exactly.
Now, a couple of times you've now mentioned a scenario where in software it might be a great solution, but in hardware you say no, that's not even possible, or that won't achieve the results that we want. It might look nice, and I imagine looking from these two directions. From a hardware perspective, you ask a software person, hey, do you think it would be possible to change this or that in the code? And the answer is probably always yes, it is possible.
Yeah.
But then the other direction, from the software side, looking at the hardware and saying, hey, do you think it would be possible to change this and this? The answer surprisingly often is no. We can't adjust that device with those settings.
Yeah, exactly. That's the case, right? Or let's say the cost of changing it is maybe too high, right? Because you can't easily change that. So yeah, and that's the different worlds that I think need to understand. And at the end, I think it all depends on your openness, right? So if you're open enough and willing enough to learn those kind of things, I mean, you will do it and you will succeed.
Those software engineers, do they tend to work closely with the hardware engineers from the very beginning steps of the project to be able to understand realistically what is important, what data must be collected, what sort of analytics are even going to be meaningful, and what results are going to be achievable? Do they tend to work together from the beginning, or is that kind of in isolation until the project reaches a certain stage?
From my perspective, they should be part on a project from day one, because you need to bring this knowledge together. Otherwise, it's not working, and it's also more difficult to succeed. So I would say from day one, involve them, involve the different disciplines that you need, right? So also, like if you think about a facility, you might also have IT, which might be involved in and such things, because when it comes to software, oftentimes IT is involved, right? So they also want to have or spend at least a few words on it, on what you want to achieve. So also those kind of disciplines are then oftentimes involved. Maybe not the full time of the project, but at least in the early stage conversations. So when we typically do projects, we really have oftentimes many people of different disciplines sitting in there, right? So depending on what you want to achieve, right? So could be a maintenance person, could be the user of a machine, could be of course the management, which might have an interest on where do you spend your dollars. It might be might be IT as well, like I said, right? So or the hardware engineer. So that means really like you have all these different disciplines sitting together. But I think if everyone looks on the same goal, having the same perspective and thinks about a certain challenge, that's where you can succeed then.
So you've worked with many IIoT projects, and probably a common denominator across all companies that produce or run some sort of production equipment is that they'll have people that operate their production equipment, the hardware-centric engineers. But not every company is going to have a department devoted to software development. I'm sure most big companies do, but a lot of small companies have no such people. What is their recourse? Do they tend to work with companies like Emerson to be able to act as the software expert in the room? Do you recommend that those companies go and find somebody or an outside consultant to be able to bring in? Again, a trustworthy one. Consultants, there's a lot of variety in the kinds of consultants that are out there. But what's usually your recommendation or your recourse for those companies that really are too small to have that in-house expertise in software?
Yeah, I think you definitely need to have an expert, or you should contact an expert. Could be a company like Emerson, for example. There are a lot of integrators as well, of course, that have this kind of knowledge as well. That really help you on also to set such a project up, so to speak, to define the starting point, who ideally maybe also already did such kind of projects, because that helps you. Also, when you look on the timeline of such a project, for example. So that would be my recommendation if you want to make the step more towards software. that you really talk then, to the experts that you maybe know or have around you, of course, or you search for a supplier, of course.
Diving down into this a little bit more, the statistics of sensing, would you say that there are some parameters in sensing that are more useful to the analytics side, or maybe that's situation dependent? Things like repeatability and accuracy of sensors is always a discussion topic when it comes to selecting the right hardware and even knowing how to analyze the software as well. Are there certain things that you feel are very important to understand from both the hardware and software side from the beginning?
The answer is it, of course, depends. So I think you mentioned already the main things you should look at, right? So if you have a process that needs to have a very specific amount of something, of course, you're looking for accuracy within the sensor, right? Because it's needed for your process maybe, and therefore this high accuracy is needed, right? On the other hand, when it comes to data analytics, accuracy is nice, but not the main thing I would look at. Then it's way more on the repeatability, because you are in most of the cases looking on deviations of your data, and that's the reason why the repeatability will help you way more on seeing like, okay, there's obviously a behavior that is different than what I've typically seen at my machine, for example, my component. And that's the reason why these repeatability play a much bigger role then. So if you look on, come back to the sustainability topic, if you look on sustainability and you want to monitor your consumptions, you maybe look more for accuracy, for example, right? So that's the reason why the answer is it depends on what you want to achieve. But for real data analytics, in most of the cases, it's the repeatability, and it doesn't need to be the perfect sensor that has the super high accuracy.
And again, as with everything, we add the disclaimer of it really depends on what you want to get out of your scenario.
Yeah, for sure.
So I think hopefully that comes across very clearly, is that any recommendations or ideas are not meant to be this is the general solution that applies to everybody, but rather certain things that may be helpful for those who are new to the process and need some extra things to think about. And on that note, similar to what we were talking about with with the hardware engineers understanding software, when it comes to software engineers learning about hardware, I suppose probably the best option is being able to be in a company or a situation where you can get hands-on with some hardware and walk around with the hardware engineer, and they can point out, here's exactly how this control system works. But in lieu of that opportunity, are there certain things, training kits, hardware development kits that these software engineers can use to become a little bit more familiar with the more hardware-centric part of control systems, the PLCs, the sensors, the actuators, those things that they're going to see everywhere on the shop floor?
Yeah, I think my approach is always like, look in the world around you, right? And if you are an engineer and engineering excites you, pretty much also look at your house as well, for example, right? And see like, hey, what can you automate, for example, there? In my case, for example, the lawn sprinkler, for example, just using that, right, and working with some valves of water to do the sprinkling and whatnot, right? So I think you will find opportunities around you if you are really interested and want to get to this topic. And of course, I mean, that might be not 100% an academic approach, right? So you can also, of course, do these online courses that we talked about. But I'm a big advocate of just, looking at the thing, doing something, trying it out, because that helps you the most on the learning aspect, instead of, at least from my perspective, just reading it theoretically doesn't help you in the real world oftentimes. That's at least my experience. So that's the reason why I'm a big fan of really trying those things out. And like I said, look in the world around you. Look at your house that you're having and see what can you automate in that, for example, right? Could be the lighting, could be whatever, right? I think you'll find a lot of opportunities in there.
I know there's a lot of opportunities for especially inexpensive hardware kits, especially like working with my kids who are still very young, being able to get into a basic microcontroller and just turn an LED on and off
sure.
and start putting together the software and hardware side, or getting into some very
Yeah.
basic PLC ladder logic development, or whatever angle that takes. Just being
Yeah.
able to start with something simple and then starting to understand how it affects a real world kind of thing, even if it doesn't produce some really impactful results. Just being able to see how it works kind of turns the light bulb on, as it were. Well, I thank you very much for your time and your experience here. With just a few more minutes, we do have a few kind of fun questions that we like to fill the time with. We've had a lot of really great productive discussion here, but I am curious, what was your very first actual automation or engineering project? And in your case, from the discussion we've had, I would assume it was probably more software centered. But was that for something that was a hobby just for fun, or was it actually a real world development, like with your startup, that was your very first real project that you did?
Yeah, it all depends on what you consider as real, right? So, I mean, I mentioned, for example, this lawn sprinkler thing where I just used the Raspberry Pi, some relays, and some valves, for example, right? So that I automated, and then doing more and more web interface to control it and whatnot, right? Where you can really configure timings and those kind of things. These were examples. I think throughout the projects that I did in the space of IoT, maybe also to give another example, I had a very funny project in between with an ice cream manufacturer who was. It was really fun because they had these cones of ice for the ice, where they were spraying chocolate into the cone. But the difficulty for them was really like to control the amount of chocolate that goes into the cone. And they were spraying too much chocolate into the cone because, of course, in their labeling outside, they need to say how many grams of chocolate they put in. And due to they were not fully controlling the system, obviously, they put always a bit more into that. I would say, as a user of ice, I would say, hey, great, right? So, or a consumer of ice, a great thing, right? I just get more than I paid for. But for them, of course, it was real money, right? So
Right.
they really ask us like, okay, how can we, yeah, how can you help us on that? I mean, at the end, we can at least claim we made the world more healthy, right? So because the people consume now less chocolate. But yeah, that was just one of the funny projects we had really in between. So yeah.
Well, reducing the amount of ice cream, maybe that's not as much fun for the consumer, but hearing examples like that, getting to work with an ice cream company, or many different types of food manufacturing, it kind of brings just manufacturing is sort of, it's day to day kind of boring, and then ice cream, ooh, that's interesting.
Yeah.
And finally, the last question that I have for you is, if you could go back and meet any historical person, who would that be, and why would you choose that person?
I think for me it would be Tesla, because I think what he brought up to the world during the time he was living, I think was a lot. And I think speaking with such a person would be amazing, right? So yeah, so that would be the person for me.
And as a final word of insight for those listeners who might be students, or perhaps not formally students, but those that are in the learning phase, do you have any advice that you potentially would give yourself, or by extension give to those who are trying to get started on this journey?
Just start, just try things out, right? Be interested. So that would be my advice for those people, right? So because while you are doing those things, you are learning a lot. And or if you could go to a larger company like Emerson, for example, right? So the things that our students here really do and what they can try out, I think that's really cool things. And when I look back, I mean, I would thought when I was studying that would be a great opportunity to be in such a company and have this opportunity to try all these different things out, to get also in touch with the hardware in my case then. So that would be a great opportunity to utilize these large companies, because oftentimes they have programs for those kind of aspects. Utilize those. I think that helps you a lot.
Well, Nils, thank you so much for your time and your experience that you've shared with us today. I really appreciate it. This has been really educational for me. These topics are always very exciting because I come in with a background that has a limited amount of experience in some of these areas. And I'm always excited to learn more about how it works and what kind of opportunities are out there. And I'll certainly be looking forward to the next time at a trade show where I can meet with Emerson and learn just a little bit more about the Florida Cloud concept and be able to share that with some of our audience here at Control.com. So again, thank you so much for the time and experience you've shared with us today.
Yeah, thank you, David, as well for giving me the opportunity for do this interview with you. It was a pleasure, and yeah, many thanks.
And once again, our sincerest thanks to Emerson and to Nils for sharing his time and his experience with us today. And thank you to our audience for joining us today for this keynote. We hope that you will visit our featured partners' microsites filled with valuable content and watch the other keynotes and live session events, all of which will still be available on demand after today so that you can share the experience with anyone who wasn't able to join us live today. And remember, the more sessions that you register for today, the better your chances of winning one of our session giveaways or becoming the lucky winner of the grand prize, which for the first time ever, you'll have the chance to choose your own prize from our list of options or even beyond. Thanks for joining us for this Control Automation Day 2025 presentation, and we look forward to seeing you again very soon.